So the white ductwork you see here are the ducts that we use to install the post-tensioning tendons. Those are very high-strength steel cables that run through the concrete and then anchor at each end, and they are stressed to a very high level of force, and that force helps to compress the concrete and keep it from cracking. Each one of these ducts holds a tendon that will eventually be stressed to a force of about 1 million pounds. Running in the longitudinal direction and in the transverse direction, there's smaller tendons that help compress the deck in the sideways direction.
And you say that tension helps pull the concrete together so it's less likely to crack over time.
That's correct, yeah. Concrete works very well in compression. It has very high strength when you push on it, but when you pull it apart, its strength is only about 10% of its compressive strength. So we like to keep the concrete in compression and prevent that cracking from occurring, which helps with the durability of the structure. So by having a high-strength steel tendon anchored at each end, those anchors, when you stress that tendon, are pushing on the concrete and holding it all together. It's the equivalent of running a very large rubber band from one end to the other and tightening it up. Yeah, the blue and white steel structures are the Form Traveler system. The Form Traveler is a movable piece of equipment that provides a work platform and the formwork to cast each of the segments of the concrete as we work our way out from the pier table. The back end of the formwork is attached to the pier table with these anchor bars that you see on the deck here. The front end of the Form Traveler, which hangs down here, that holds up the front end of the new segment, reaches up with this structure overhead and then anchors back behind us over here on the deck of the pier table as well. So the entire weight of the Form Traveler and the new segment concrete, until it gets hard and can hold its own load, is carried by these anchorages that are attached to the pier table. Well, we mentioned the longitudinal post-tensioning tendons before, and these are the ends of those PT ducts as they exit out the face of the new segment we're about to cast. And you'll notice that one of the ducts terminates at this bulkhead for this segment, and there is an anchorage assembly that attaches to that bulkhead. That is where one of those tendons will have its anchorage, where we will stress and apply that compressive force to the concrete. So every time we build a new segment, one of these tendon ducts will terminate at the face of that new segment. And consequently, every time we build a new segment, we'll have one less tendon duct to run through it. So by the time you get out to the end, where you're meeting up with this end of the bridge or out in the middle of the main span, you end up stressing and anchoring your last tendon.
Looks like we're in the cellar. So what are we looking at here?
So these are the interior cells of this concrete box girder superstructure shape. And essentially, this bridge would be exceedingly heavy if you just had a solid section. So in order to save weight and increase the efficiency of the bridge's design, these areas are left hollow. It provides a convenient way to access the inside of the bridge for inspection, and also for running utilities and other equipment through the bridge that might be needed. But it makes for an interesting work environment. So you can see the bottom slab formwork here. You can see the vertical web wall formwork here. So
that'll be concrete in between too?
Yep, this will be essentially a wall of concrete here. You can see that back at the pier table there's a big solid section, we call that a diaphragm. And that's an area where all of the load from the bridge, the traffic and the weight of the bridge itself, transfers down into the bearings for the feet of the bridge, and then that goes in turn down to the foundation and the ground. So that's a very high load area, so it needs to have a very large section to handle the kind of loads that go through there. But we do give ourselves an access opening so that we can walk through the entire length of the bridge and be able to inspect it in the future.